Let's read this question before us. Two boxes each contain 4 stones that differ only in color. Box 1 contains 4 black stones. Box 2 contains 2 black stones and 2 white stones. A box is chosen randomly, and 1 stone is drawn randomly from it. Each box is equally likely to be chosen, as is each stone. What is the probability that the randomly drawn stone is black? Okay, so the first thing you have to do when you approach with these type of questions is actually figure out, what technique should we use here? Should I use a probability table or should I use a tree diagram? And right here, you're going to use a tree diagram because you've got like these sequential events happening. The first thing that you're doing is you're either selecting box 1 or you're selecting box 2. And you know that these are equally likely. So a box is equally likely to be chosen. So that means that's a half and that's a half. And then from each box, you're then selecting a stone from it. So for instance, if you've got box 1, what's the probability of you getting a black stone? Or what's the probability of you getting a white stone? Well, you've been told that there are 4 black stones in box 1, and that's all there are. So that means there's a 100% probability that you're getting a black stone out, but there's a 0% probability that you're going to get a white stone because there are no white stones in box 1. Then for box 2, you've been told that there are 2 black stones and 2 white stones. So that means there is a 50% chance that you're going to get a black one, and there is a 50% chance you're going to get a white one. And now it's saying, what's the probability that the randomly drawn stone is black? So that means what we want to consider is we want to consider this, and we also want to consider that. So that means I'm going to go, what is a half times 1? Well, that's 1. And over here, I'm going to go, what's a half times a half? That's going to be, a half times 1 is a half. My apologies, people. And a half times a half is 1 on 4. And then once you've done that, you simply go, therefore, a half plus 1 on 4 is going to be 3/4. And that's going to be your answer. So don't be like me, don't make stupid mistakes. A half times 1 is a 1. What was I thinking? All right, there we go. 3/4. We then move on to our next one. It is not known from which box the stone has been drawn. Given that the stone that is drawn is black, what is the probability that it was drawn from box 1? Okay, so we've got a given question here. So that means we're dealing with conditional probability. And we're told that it's given that the stone being drawn out is black. What's the probability that it was drawn from box 1? So what's the probability that it's box 1 given that it's black? So 1 given black. We know that this is going to be the probability of 1 intersection of B over the probability of B. Now, it's really important when you're doing these questions that you kind of take note of what you've already figured out or what they've already told you. And here, we've got the probability of pulling out a black stone. Well, we've already figured out the probability of pulling a black stone, haven't we? This here was the probability of pulling out a black stone. So we know that our denominator here is going to be 3 on 4. So that means if I was to rewrite this, I could say, I don't know what this is yet, but I know that it's being divided by 3 on 4. That we know. And now, if I want to figure out what the probability of 1 intersection of B is, I'm going to come back up to this one. I might highlight this in green. I'm trying to figure out this. Well, what's that going to be? The probability of 1 intersection of B. Well, that's going to be this one right here. So the probability of 1 intersection of B, that means you've got box 1 and you're pulling out a black. So that's going to be a half. So that means I'm going to come here. I'll try to keep the colors consistent here, people. That's going to be that. That will be green. And we come down. Is equal to, now this is where we use our trusty stay, change, flip. Stay, change, flip. And then we can cancel this down a little bit. That will become 1. That will be 2. That means my answer will be, wait for it, 2 on 3. That is our answer. Now, this was a Year 12 question, but as you can see, very much accessible to us at Year 11. This is definitely a question that we should expect you to be able to do. Nothing too tricky here, just making sure that you can think through everything clearly. Hopefully you enjoyed it. I'll see you in the next one.